Good morning, everybody. Today we are going to learn about Jacobi iteration method. It is an iterative method for solving linear equations using Python or any programming language. It is a beginner-friendly introduction to numerical methods for solving system of linear equations. The introduction says a system of linear equations is a set of equations with multiple unknown that must be solved simultaneously. There are two main approaches: direct methods like Gaussian elimination solved in finite steps, while iterative methods use repeated approximations for large systems. Iterative methods are essential as they require less memory and computational resources. Here the Jacobi method uses repeated approximation to reach solution. Start with initial guess for all variables, then update each variable using values from previous iteration, and continue this process until the value converges, meaning changes between the iteration becomes negligible small. Here the code formulas isolate each variable using values from the previous iteration. Like you will see here v minus a1 to y minus a1 3 z, v2 minus a21 x minus a23 z, b3 minus a31 x minus a32 y, and then divide them by diagonal elements. Here new values of x, y, and z are computed using only the previous iteration value of all other variables. Now here are the original system of equations given to us. Now we will arrange them for the Jacobi iteration by arranging their coefficients. So this is the equations after Jacobi arrangement, and we will take initial guess and x0, y0, and z0. Okay. Now iteration 1 will give us x equals to x1 equals to 0.6, x y1 equals to 2.273, z1 equals to minus 1.5. Then second iteration give us these values. Then third iteration we will get another values. Noticing how value approaches a stable solution with each iteration, the changes between the iteration become smaller, indicating converge toward x going to 1, y converges to 2, and z converges to minus 1. Now the final answer after the solution we will get x equals to 1, y equals to 2, and z equals to 3. These values satisfy the original system of equations. Jacobi method successfully approximates the solution through repeated iteration until changes become negligible and small. Now you can see the algorithm flow. Firstly, we will start the program, then take the input of equations and rearrange the equation for each variable. Assume that initial value x, y, and z0 equals to 0. Compute new values using formulas, repeat iterations, check convergence, small changes, and then print solution, and then stop. After that, there is a Python program. Firstly, there are initial values we have taken x, y, z equals to 0. For I in range of 10, x1 equals to this, y1 equals to this, and z1 equals to this. For x, y, z equals to x1, y1, z1. Print iteration I plus 1 x for 4 floating value, 4 floating point, and y for 4 floating point, and z for 4 floating. Now we get the output value which converges to x converges to 1, y converges to 2, and z converges to minus 1. Which is main applications are engineering analysis, structural computations, scientific computing, and research simulation, numerical simulation in physics and chemistry, a large-scale matrix computation in data science. That's all about the Jacobi methods. Thank you. The Jacobi method is a fundamental iterative technique for solving a linear system. It uses repeated approximation to converge on the solution, making it easy to implement in Python. Particularly, this is large the direct method become computationally intensive. Thank you. That's all about the Jacobi method. Very good.